We have discussed the main ideas behind the quantum computing protocol. We introduced the concept of a qubit and also figured out how to transform qubits to talk about the universality of quantum computing. Now, let's talk about how these ideas can be put into practice. There are many models of quantum computing nowadays. All of them are based on the basic principles of quantum computing, but they all differ in how they are practically implemented. The first proposed models of quantum computers were conceptually very similar to the models of classical computers. In these models, devices that perform elementary unitary transformations were used to perform operations on input states. That is to say, devices that implement this or that gate. We had to send input qubits in certain states sequentially to these devices. As a result, we would be able to implement universal quantum computing. The slide shows the simplest scheme that can implement some transformation over 3 input qubits. The described model is called the circuit computation model because any algorithm can be associated with some implementation circuit. This model is very simple conceptually, but it is similar to the familiar model of quantum computing. However, this model is difficult to implement in practice. One of the main problems in its implementation is that qubits in a superposition state are highly susceptible to decoherence. Decoherence is the process by which the state of a qubit is destroyed when interacting with the environment. It seems obvious that to solve the decoherence problem, it is necessary to isolate qubits as much as possible from interaction with the environment. However, a problem arises here, since it is impossible to completely restrict the qubits from the external environment. As we found out, qubits must interact with each other for us to perform controlled 2-qubit logical operations. These operations cannot be performed if the qubits are completely isolated. For this reason, all protocols implemented in practice have only a small number of qubits. Unfortunately, this is not enough for the superiority of quantum computer over a classical one. This contradiction has led to the search for alternative computation models that are more difficult from the point of view of theoretical understanding, but easier to implement in practice.